recognizes himself for 5 minutes. And all of the testimony was fascinating, especially what Mr. Weir just said, and centrifugal force and spinning, creating artificial gravity. But another problem, when we send our astronauts beyond low Earth orbit, we're exposing them to the dangers of deep space radiation. And without the Earth's protective magnetic field, future explorers are vulnerable to ionizing radiation, solar particle events, and galactic cosmic rays, which pose an increased risk for cancer. This is perhaps the most serious scientific challenge that we face on the journey to Mars. And I'm wondering how we protected Matt Damon that entire time from this radiation and had him return safely. But what kinds of technologies, and this is a question for all of you, what kinds of technologies are being developed that protect our astronauts from deep space radiation? What are some of the ideas? How are we integrating radiation protection into our deep space habitation designs? And I would appreciate an answer from any one of you or all of you.
So I'll start. Currently, we're doing investments in a couple different areas. First and foremost, the monitoring of events, starting with our heliophysics efforts of monitoring the sun on an ongoing basis, and then actually figuring out the modeling effects of the transfer from the sun into wherever our spacecraft should be. And then actually doing high-quality monitoring of the actual radiation particles that come when they get there. All of our studies, internal and the ones we're doing under the Next Step analysis as well with the commercial folks, are looking at optimizing the ability for storm shelters and deployable storm shelters and the integration of things like water walls into crew quarters and such. That helps with your SPE events and such. Galactic cosmic rays are still a challenge, and there isn't any current technology to address the high energy of GCR beyond the ability to monitor it and factor it in the overall dosing that we have. And I'll leave it to my colleagues to add to that.
Thank you, Mr. Cruzan. Frank, Mr. Culbertson?
Yes, sir. My personal experience was that NASA spends a lot of time investigating what's happening to the astronauts, both while they're in space and after they return. We go through an annual physical to see whether there are any residual effects, and the effects that Mr. Weir talked about are there and real, and we do a lot of exercise and other countermeasures. The radiation aspect is a serious one too, and when you leave, as you said, the magnetosphere, you're exposed to it much more, and the types of technologies that Jason mentioned, such as water protection, there's also PVC. People are working on actually superconductivity as a potential way of protecting the crew inside. But I think if we use the opportunity to go to cislunar space, and when we first have a module arrive, have enough sensors on there to really characterize the interior of what the crew might be exposed to when they arrive later, then we might be better prepared. And of course, if we start with the short missions there and investigate the effects on the crew before we actually send them on the long voyages, I think we'll learn a lot. I do think we will figure out a way to counter this. I don't think it's impossible.
Same here. Mr. Weir?
Yeah, I'll just speak to that a little bit. First off, NASA recently upped its acceptable radiation limit, lifetime limit for astronauts if in the event that that these astronauts were going to the moon. So first off, a lot of this, believe it or not, is solved by a simple policy decision. I was a very, very diligent fan sent me a paper that he wrote and later got published about the radiation dosage received by all of the members of the Ares program, including Mr. Watney on the surface of Mars, and actually found that the worst of them would have been exposed, would have had an additional 4% mortality likelihood, and that would have been actually the CISOP, Beth Johansson, played by Kate Mara in the movie. She would have had the highest mortality odds added to her, because while Mark was on Mars and Mars was guarding him from half of the galactic radiation that might be getting at him, the rest of the crew were in space that entire time. And Johansson is the youngest, and she's female, both of which are things that increase your mortality likelihood from radiation. But just to be clear, we're not talking about people dying of horrendous radiation sickness. We're talking about a slight increase in mortality, and astronauts are willing to take risks. So on the surface of it, I don't think that much needs to be done at all. And then finally, the best way to deal with radiation amelioration is mass, just putting water between the astronauts and the sources of radiation, and getting more mass to LEO. If you want to do that, fund. Put more money into private space travel. They'll drive the price down.
Amen. Amen. I think that expands my, unless either one of you would like to add to that?
No, I think we covered it. The best solutions that we know of take a lot of weight, so we have to work
Yes.
through that whole scenario.
Right.
I have very little to add, only that we're going to get smarter. The very first mission that we make, Exploration Mission 1, will have sensors and information that we'll be able to use to figure out which of these potential solutions make sense for us. We're also looking at individual protection strategies for astronauts, and that might also be something that would be fruitful as we go forward. So there's more to come.
You bet. Thank you, Mrs. Segura. You know, I've got a couple of staffers in here I wanted to introduce real quick, and Will Carter and Lauren Jones, and also my wife, Roxanne, is sitting back there. I just noticed them there. Thank you for being here. Now, next, I'd like to hear from the gentlewoman from Maryland, Ms. Edwards.